In this video, we will learn about the basics of feature engineering. Feature engineering is key in extracting the right attributes from raw incoming data for building better ML algorithms. A feature is every unique attribute of data in a dataset. Consequently, feature engineering comprises of transforming features, generating new features, extracting features from the existing data, and selecting features along with feature analysis and evaluation. Now let's look at the feature engineering process. The first step in feature engineering is feature creation, in which relevant features to a problem at hand are identified. Then comes feature transformation. At this step, any missing features are created or invalid features are replaced to ensure consistency of the available datasets. This is typically done using existing features by applying mathematical operations on them or by using nonlinear transformations such as categorizing numeric data into non-numeric attributes. Then comes feature extraction. This is the process of creating new features with overall goal to reduce dimensionality of the existing features. Then the last and important step of feature engineering is called feature selection, where features that are redundant or not important are identified and removed. The reduction in the feature set size reduces the computational loads on machine learning algorithms and therefore can improve the quality of the machine learning output. In this video, we will understand how dimensions and features are linked to each other and their impacts on building accurate ML models. Dimensionality reduction is a process of reducing the dimensions in a feature set. In other words, it is the process of reducing the number of attributes in a dataset. First, let us look at the dimensionality dilemma. As the number of features increase in a dataset, the number of samples or observation in the dataset also increase proportionally. This is helpful in creating a diverse set of training data to build and train machine learning models. However, as the number of features increase, the complexity of the algorithm and models also increase. This often can lead to overfitting of machine learning models, where they end up getting trained and thus depend on large number of features, resulting in an inaccurate predictive performance using real-world data. Therefore, there exists a dimensionality dilemma, where we need to find the right balance in the number of features used for a problem at hand. Thus, it is essential that we have optimal number of dimensions used in the training data, as model accuracy improves by eliminating irrelevant and misleading data. Next, let us look at how we can use feature engineering for dimensionality reduction. Feature engineering can be performed to reduce dimensions in an existing dataset by a manual process or programmatically. A simple manual feature selection and dimensionality reduction process could be performed by visually inspecting the dataset and removing features that are glaringly irrelevant to the problem at hand. Other tools such as creating heat maps to visualize the correlations between features or plotting each feature against the target variable can also be used. A common programmatic way to reduce dimensionality is by applying a variance threshold technique, wherein all features that have low variance are removed as they contribute negligibly to predictive models. In this video, we will understand what is Amazon SageMaker and briefly learn about its capabilities. Amazon SageMaker is a cloud-based platform that enables data scientists and data engineers to build, train, and deploy efficient machine learning algorithms quickly. SageMaker has advanced capabilities and purpose-built tools for every step in machine learning modeling, including data labeling, data preparation, feature engineering application, detection of any statistical bias in the data, training and tuning machine learning models, and finally deploying and monitoring them. SageMaker provides an integrating development environment for machine learning where users can use a single web-based visual interface for every step in machine learning model development and deployment. SageMaker has an autopilot capability where it can automatically build, train, tune machine learning models by selecting an appropriate algorithm based on the dataset at hand. SageMaker also offers a feature known as ground truth, where users can label data automatically for a variety of use cases. In summary, SageMaker eliminates the difficult steps at every stage of the machine learning process and makes it easier for users to develop very high quality machine learning models faster and with less effort. In this video, we will learn about the Amazon SageMaker feature store that is a new tool to fully manage repositories for ML features. SageMaker offers a repository that is purposefully built to manage, store, update, and retrieve features for machine learning. Performance accuracies on any machine learning models are very dependent on the features. Therefore, it is essential to ensure consistency and availability of features across different access points in an organization. For example, data points from the same feature can be used for training and predictions concurrently for different machine learning models. The Amazon SageMaker feature store then becomes this repository where users can usually store and access features for training as well as making real-time predictions without writing any additional code to ensure that the features are consistent across the board. The feature store also constantly updates features with new data as it's being generated. Feature store primarily keep track of the features by closely monitoring the metadata in real time. Feature Store has the ability to ingest data from a variety of sources across the AWS platform. The data can be ingested in the batch form or from streaming source as well. One key capability of the Feature Store is feature standardization, where it eliminates any confusion across an organization by storing feature definitions in a single repository, thereby ensuring the feature is clearly defined, making it easier to use across different applications. Hi, in this video we will learn how to use AWS SageMaker feature store to achieve consistency and standardization of data. We will use AWS SageMaker Studio for this. To begin, let us first log in to the AWS SageMaker console from AWS Management Console. For that, let us use the search bar on top of the screen to type in SageMaker. The search result that reads Amazon SageMaker is what we need, so let us click on that. This should be the top search result in the window. Now we are on the SageMaker console screen. First, let us go to the SageMaker dashboard on the left panel. For that, we can click on the dashboard button. I'm scrolling a little down in the center screen. We are given details from SageMaker Studio. Here, using the SageMaker Studio, we can prepare, build, train and tune, and deploy and manage our ML applications. The feature store is part of the prepare section of the AWS Studio. Now, in order to access the SageMaker Studio, let us click on the Amazon SageMaker Studio button on the left panel of the screen. On my screen, this is the top option on the left pane. Under the SageMaker Studio control panel, we can see a list of users that have access to the Amazon SageMaker Studio. Here, on my screen, there is only one username that has access to the studio. In order to access the Amazon SageMaker Studio, we can click on the Open Studio button corresponding to the username that we want to open it for. On my screen, the button is located at the right of the center screen. Now, while our SageMaker Studio is opening up, let's hang in there. Now, we are on the Amazon SageMaker Studio console screen. We will use this console to access SageMaker Feature Store and create a feature group. In order to start, first we can use the Components and Registries icon on the leftmost navigation pane. This on my screen is the last icon in the leftmost navigation pane. On clicking this icon, a Components and Registries panel open up on the left of the screen. Using the drop-down in the same panel, we can access Feature Store and many other options. For our purpose, let us choose Feature Store. Under the same section, we have two options, one that reads Feature Store and the other that reads Create Feature Group. First, let us access Feature Store. On the right center of the screen, a Feature Store section opens up. Under the Feature Store section, a list of feature groups are listed. A quick recap on feature groups is that feature groups are created inside the Feature Store. These groups can be accessed by multiple machine learning models that can be run on your account. So, let us say that you're running multiple machine learning models for FX trading markets. And these models then must have some kind of a price table that is repeating in all of the ML models. In that case, we can create one feature group that can be accessed by all the ML models. In order to demonstrate, let us create one such feature group. In order to create our first feature group, let us click on the Create Feature Group button on the top right of the Feature Store area. On clicking on the Create Feature Group button, a new tab on the SageMaker Studio has opened up. Here, we are required to configure the feature store. The first step is to give an appropriate name under the feature group name and give an appropriate description under the description header. So first, let us give an appropriate feature group name. Let me call this daily-price-volume. And under the description, I can give an appropriate description saying time series data of price and volume. In the next configuration step, we are required to give feature group storage configurations. Here we can pick between two options, either from enable storage online or enable storage offline. We can even choose both of these options. Under the enable storage offline option, our data will be transferred to S3 bucket automatically, whereas that won't be the case in storage online option. For our case, let us only enable the storage online option. To enable only online storage, let us check the box next to Enable Online Storage option. Under the online storage option, we can choose to encrypt our data by providing an encryption key. In order to do that, we can simply click on the drop-down button and give the appropriate key ARN. For the demo purpose, let us proceed without using any encryption by using no custom encryption option. Once this option is selected, we can click on the Continue button on the bottom right of the screen. On the new screen, we require to give feature definition of our feature group. Simply put, feature definitions are just unique names for our columns along with their data types. We can give up to 2500 feature definitions. To configure our feature definitions using the console, we have two options. One, by using the JSON editor, and the second option is by using the table option. For our case, we will be using the table method to configure the feature definitions. The table method can be accessed by clicking the table button under the feature definition area. The table is not appropriately displayed on the center of the screen. This is a glitch in AWS console. Just to clarify, it has four fields, namely order, name, type, and action. The order field defines the priority order or the sequential order. Under the name field, there is a user input text box that we will fill in to give our field name. And thirdly, the type is the data type of the corresponding field name. First, let us give the field name as ID. We can select the data type equal to be an integral. Then we can click on the second row to give an additional field. We can call our second field as price and give the data type as fractional. The data type can be accessed using the drop-down menu next to the field name. We can give a third field, namely volume, with a data type equal to fractional. Following the same process as we did for the first two fields, let us give a fourth field that's called time, with the data type equal to string. Once we have set up the feature definition as per our requirement, we can click on the Continue button on the bottom right of the screen. Under the next step, we have to configure two things. First is to configure the record identifier name. A record identifier will be a primary key or a unique key for our feature definition. So let us use the record identifier drop-down to pick the record identifier. In our case, this will be ID. Following the same process, we have to give an event time feature name. Using the appropriate drop-down, we can select the event time feature name. In our case, that will be time. Once both these options are set up, we can click on the Continue button on the center right of the screen. The fourth step is an optional step where we can give feature group tags. Since in our case we need not give any feature tags, let us click on the Create Feature Group button on the center right of the screen to finish the task. Now a notification window on the top of the screen says that our feature group is successfully created. That means we will be able to use the daily price volume feature group for our multiple ML models. Following the same process as we did in this video, you can create multiple feature groups as per your requirements. I would now urge you to try this for yourself, and do note that Amazon SageMaker keeps adding new capabilities to its feature stores. In this video, we will learn about the Amazon SageMaker ground truth and its major benefits. We will also see how it works. Ground truth is a data labeling service as part of the Sagemaker Console. Ground truth can handle video, images, and text data and can label the data automatically or route it through manual labelers. The manual labelers have access to unique features such as distortion removal, 3D cuboid snapping, and auto segmentation to assist them in labeling the data faster and with higher accuracies. Now let us look at the workflow of Amazon Ground Truth. The users create a labeling job that is customized or select one of the built-in flows for data labeling. Then the raw data is accessed from Amazon S3 and sent to different group of labelers. Once sent to labelers, the data is labeled manually or by using assistive labeling features that are offered on Ground Truth. Now, let us learn about the benefits of Ground Truth. Ground Truth uses annotation consolidation, which is simply collecting label inputs from two or more data labelers and then combining them to create a single data label for machine learning models. The annotation consolidation process helps to improve the quality of the labels and make necessary adjustments to improve accuracies. The automatic labeling features offered as part of Ground Truth provide an intuitive interface to users to reduce time needed for labeling tasks. Ground Truth uses an active learning model where the data is labeled automatically and can also be sent to human labelers if the model is not confident about its accuracies. Further, the human label data is then used as training to improve machine learning models' accuracy. Over time, less and less data is sent to human labelers, thereby reducing labeling costs significantly for users. Ground Truth enable users to send labeling jobs to internal labelers or to a workforce of 500,000 independent contractors with specific labeling skills across the globe. Hi, in this video we will use SageMaker Ground Truth to label the data. The data labeling process makes it easy for us to build highly accurate data sets for machine learning processing. And Amazon SageMaker Ground Truth is a fully managed data labeling service. In order to begin, let's log into the SageMaker console from our AWS Management Console. For that, let's use the search bar on the top of the screen to search for SageMaker. Now, let us click on the search result that reads Amazon SageMaker. On my screen, this is the first search result. On clicking on Amazon SageMaker, we will be taken to the SageMaker console. Now, from the SageMaker console screen, we will create a labeling workflow in Ground Truth. As a prerequisite for our demo, we have in an S3 bucket saved a set of unlabeled data, which in our case are a set of unlabeled images. For the purpose of this demo, the content of the images is not important. Now, let us start with the setup of Ground Truth. In the first step, we will create a labeling job where we give Ground Truth access to the Amazon S3 path and configure other parameters for the job. To get us started, let us navigate to Ground Truth option on the left navigation pane. Next to the Ground Truth label, we can click on the arrow button to expand its features. Under Ground Truth, let us click on the Labeling Jobs option. Now we are taken to Amazon SageMaker Labeling Job Console. The area in the center screen gives a list of all the jobs that are active. To create our job, let us click on the Create Labeling Job button on the top right of the screen. Now, on the new screen, we will configure the labeling job as expected by Amazon SageMaker. The first step, however, is to give a job name. Navigating to the text box under Job Name, we can give an appropriate name. Let me call the labeling job as Label Dogs in Pictures. By default, ground truth will store the labels under an attribute that matches with our job name. If we want to set another attribute name, then we can check the attribute name box next to the statement, I want to specify a label attribute name different from the labeling job. However, in our case, let us proceed with the box unchecked and proceed to the next step. On this step, we will continue with automated data setup option selected and proceed to give the location of our S3 object. Here, we are required to give the location for both input dataset and output dataset. We can also choose the output dataset to be same as the input dataset. Let us first enter the location for input dataset under the data setup option. We can manually write the location to be S3 colon 2 forward slash. Then we will have to give the bucket name. The bucket name in our case is Sagemaker hyphen data hyphen labeling. Then with another forward slash, we give the folder name where the input files are stored. That will be input in our case. And end the path with another forward slash. Then we choose to keep the output dataset location same as the input dataset, and we can scroll down. On scrolling down, we have to use the drop down under data type to pick the data type of our objects. In our case, we are using images, so we will use image data type. In the next step, we have to use the IAM role drop-down to select the appropriate role. Since we already have a role created, we can use that. Otherwise, you can create a new role as well. On scrolling down, we have to pick up the task type for the image category. There will be a number of options to select from. In our case, we will be using the bounding box option. Now, we have completed the first configuration step and can proceed to the next step by clicking the next button on the bottom right. On the next configuration step, we are to configure the workers who would be working on the data labeling jobs. Here, we are given three options. First, where we can choose an on-demand workforce of independent contractors who would label our data. They would label our data as per the instructions provided in the job configuration. Secondly, we could use a private group of people to label our data. And thirdly, we could use third-party vendors who specialize in data labeling service. It is advised that when we are setting up any job for the first time, we choose the private workers option and only open the labeling job to contractors or third-party vendors when we have verified the job is successfully created. So let's proceed with the private worker type option selected and proceed to give the team name. Using the private team dropdown, we can select a name of the private team. If there is no private team created, you can choose to create your own private team from the same space. Leaving other options as default, we can scroll down to give the properties of our job. Here, we are required to enter a brief description of the task. We can describe the task as use the square tool to inscribe all dogs in the image. Then we can add up to 50 labels. Here, we can add just the first label as dog, add another label called puppy, and scroll down to the next step. Now we have successfully completed the second step of configuration of our job. So let us click on the Create button on the bottom right. Now A job is getting created and we will be taken to the ground truth console screen. From this console screen, we can monitor the list of labeling jobs that are running on our ground truth account. We can monitor the name of the job, the status, the task type, and the number of objects labeled in total, and the creation time. On the left navigation pane under ground truth, we can navigate and monitor other labeling workflows such as datasets or labeling workforces. I urge you to try the labeling job yourself before giving access for labeling to contractors or to third-party vendors. Good luck. In this video, we will understand how missing data impacts ML models and ways to deal with the missing data. First, let us understand what is simple data imputation. The process of identifying and replacing missing values for each attribute before creating machine learning model is called missing data imputation. Imputation could involve using a simplistic replacement of missing values by mean, median, or mode of all other existing values, which often results in acceptable performance, or can involve creating a statistical predictive model for imputing missing values. Now, let us look at the categories of missing data. The first category is when the data is missing completely at random, wherein the missing data has nothing to do with the observations and can be attributed to equipment malfunction or some other mishap while transferring or recording the data. This form of missingness of data generally doesn't affect models as the data set still remains unbiased unless the percentage of missing values is large. The second form of missingness is called missing at random, whereby missing data in an attribute, say A, is related to some other fully observed attribute, say B. All the other cases of data missingness are classified as missing not at random, where the missingness is specifically related to what is missing. In such cases, it becomes important to estimate the missing value without inducing biasness in the data. Now, let us look at some of the ways to handle missing data. The most common way of data imputation is to simply omit cases where data is missing and analyze remaining observations. This is acceptable in situations where sample sizes are large. In other more complex approaches for data imputation, one technique involves imputing missing values using the last observed value being carried forward or the next observation carried backwards. This technique is commonly applied to time series data. Another simple mathematical technique to impute missing data is to linearly interpolate the variable and calculate the missing values accordingly. A very widely used method is to treat the missing values as an additional category or label of the variable. For example, replacing missing values by a label missing. Other ways to impute missing data includes replacing missing values by the most commonly occurring value in a variable or by replacing missing values by a random arbitrary chosen variable. One other more complex data imputation technique involves using statistical models. Commonly, linear regression is used to impute values that are missing, and in doing so, standard deviations and distributions in the dataset are retained to a large extent. Missing values can also be computed using machine learning algorithms such as random forest, which uses multiple decision trees to estimate missing values. Or we can use k-nearest method, which estimates the values that are missing based on the distance measured to neighboring points. Generally, multiple imputation techniques are used to eliminate or replace missing data without inducing any bias to the dataset. In this video, we will learn how skewed data or imbalanced data can affect ML classification, and we will also discuss ways to address the problem. Imbalanced data is a common problem that occurs in machine learning classification, wherein certain data classes have a disproportionately large ratio of observations. Such imbalance in data is often found in real-world datasets, including use cases such as spam filtering and financial fraud detection. Imbalanced data affects the performance of machine learning algorithms as they typically work best when number of observations are similar in each class. Let us now discuss some techniques to deal with imbalanced data. Sometimes it helps to change the machine learning algorithm to one that are better suited to deal with the imbalanced data set, such as deploying decision trees where an if-else equation hierarchy is used to effectively deal with imbalanced classes. Another technique includes where performance matrix for imbalanced data sets can be changed from accuracy to other metrics such as precision or sensitivity or confusion matrix. A confusion matrix is a table showing correct predictions and the type of incorrect predictions. Thirdly, imbalanced data can be resampled by oversampling the minority class, where samples are randomly replicated to create more instances. Resampling can also be done by undersampling the majority class by randomly removing samples in the majority class. In this video, we will understand how data outliers impact data analysis and the common ways to deal with data outliers. First, let us review what are data outliers. Data outliers could be explained as data points that are distinctively different from the rest of the data at hand. For example, in a variable that is normally distributed, the observations that lie more than 3 standard deviations from the mean in any direction can be considered as an outlier. Outlier can be a true outlier or could be a result of mistake in collecting the data. Now, let us discuss some approaches in dealing with outliers. One of the common approach to deal with outliers is to simply drop outlier records to avoid skewing of the analysis. Another common approach is to cap the datasets to a certain value, and any data point beyond the cap level can be considered to have the same capped value. In another approach, an outlier can be replaced by using a data imputation technique, especially when it is ascertained that the outlier is the result of a mistake in data collection. Lastly, the data can be transformed to deal with the outliers. For example, we can change the scale of the dataset from linear scale to a log scale. In this course, we learned about feature engineering and the dimensionality dilemma. We also learned about Amazon SageMaker along with feature store and ground truth. After that, we saw a demonstration for both Amazon feature store and ground truth. And at the end, we discussed various ways how we could handle missing and imbalanced data and data outliers. In the next course, we will learn about feature engineering techniques.